What's really nice when you use parametric design is you're doing systems. So it's not like a finished thing ever. It always evolves from one form to the other. And so it's creating systems instead of forms. I find that's really refreshing because you're always writing the algorithms. So this, for example, is what we put below the man at Burning Man. So you had a few of those around. And basically we let the material sort of sag. And so he created these domes inside these shells. In this case, it's a failure that worked. This is ceramics. So ceramics has been a really...
It's printed.
Yeah, it's printed. So
it seems like an organic,
yes,
natural...
it's like a coral, right?
Yeah.
Yeah. Here, it's a nice hat as well. AI is like the ultimate mood board. But it's a mood. It's a feeling. It's like Tinder, right? I like, I don't like, I like, don't like. The hard bit is it's what's behind. It's how to bring this to life. Thankfully, they stopped me when I said I want a metal shop.
No, Arthur.
No.
Hey guys, welcome to PA Talks. In this episode, we're thrilled to have Arthur Mamou-Mani, a renowned London-based architect and visionary from the world of parametric design and digital fabrication. As the founder of Mamou-Mani Architects, Arthur has been at the cutting edge of integrating parametric design with ecological principles, bringing to life stunning projects such as Galaxia Temple for Burning Man. This episode is a unique blend of office tour and interview where Arthur shares incredible insights about his inspiring journey. Join us as we dive into the world of parametric design, AI, 3D printing, and digital fabrication, discovering how Arthur's groundbreaking work is influencing the future of architecture. Before moving ahead, let's take a moment and spotlight Pacademy, an online architectural educational platform dedicated to the exploration of parametric design, computational tools, and artificial intelligence in architecture. Pacademy serves as a bridge to advanced design techniques, fostering collaboration with pioneering architects and designers. Through the online courses at the Pacademy, we dive deep into the multifaceted world of computational design, engaging with a wide array of topics that push the boundaries of architecture. You can register and join the live workshops or watch the previous studio workshops recordings. Don't forget to subscribe to our YouTube channel and hit the bell notification so you don't miss any new uploads. So if you guys are ready, let's get into the podcast. Well, thank you so much, Arthur, for having us in this office. It's great to meet you for the second time in the whole relationship in the last couple of years. I see you have a cool office. This is a new office that you've got. Yeah, congratulations. Thanks for having us.
Thank you, Hamid. Such a pleasure. I know we met online.
Yes.
And we had a session together, a really nice interview, yes. Where we were in a previous office. And slowly, thankfully, we grew a little bit. And now we have this office here. And then we have our factory next door, wow. The FabPub. And here is our architecture studio. So there's quite a lot to see.
That's great, that's great. So we're gonna go for a tour. So guys, please stay with us and we're gonna have a small tour going around about the factory and also inside the office, seeing what Arthur and his team is doing. So stay with us. Yeah, let's
Fantastic. Go. We have quite a few people, designers. We also have artists. We have people that work on materials, on robotics. So it's quite a mix of people that work on both the architecture studio and the fabrication side. Always wanted to have a holistic place that thinks from design to making, which is quite important. We're often quite disconnected from the output. And so I thought it was really nice that we could literally just touch what we design. The other thing that was important is to open up the technology to others, which is why we did the FabPub for Fabrication Public, yes. Which means that everything we would develop, we could actually have other people, the community. We have really great neighbors like Asif Khan and so on. They all come to use it. Cool. And it's been really nice to open up and foster collaborations. Yeah. Well, you know, Grasshopper, parametric design opened up the relationship with the output. So for example, do you remember Silkworm, which was a plugin we did for 3D printing? Yes, so this was a really good link with the printers. In fact, that was one of the first things I did, was to kind of assemble a 3D printer, a small one. And it was a long time ago. I still have it, actually, I'll show you. But then after that, the printers just grew and grew and grew, and our understanding as well, and also all the experimentation around it. So here's my little desk there, here.
I like that you're also next to the team. You don't have like a special room for yourself, and you're just working right next to the team. You're part of the team.
I think it's really nice to be just quite horizontal. We all work together, we all share together. So it forms like a real united team without too much of a top-down notion.
Absolutely, it's totally against it, and I don't like that one as well.
I really believe in sharing, constant sharing. That allows us to create a body of work that's coherent, where people are, they feel a part of it, as opposed to it being imposed, you know. So here's my favorite shelf of all the little stuff that we do. So yeah, you'll recognize. So this was in the middle of Galaxia, which was the Temple of Burning Man. This was what we did just after Galaxia, which was Catharsis.
Catharsis, yeah, you did also the metaverse version of it.
We did the metaverse. So this project was like pre-COVID, during COVID, post-COVID.
Oh my God.
And now we're actually reinstalling it in a new location permanently. So it will be really exciting to see it there. We actually, when we built it, we didn't actually finish the crown. So it will be the first time we do it fully. This actually was, it's a sort of fractal geometry where people could enter and explore
different set of locations.
Yes,
and
exactly.
Maybe
and get
exhibitions,
lost.
kind of.
It was very playful. We had Refik Anadol. He projected math. That was such an honor. He came by to install it as well. That's what's really nice about Burning Man, is how everyone collaborates together. Similar spirit to this office, and it's influenced us a lot because it was this idea that everyone is the artist. There's no spectators, so everyone was active into the making of the city. So yeah, so we have quite a few things. I mean, you can see on the walls our projects. The Tower of Buma in Bali, which will be finished by July.
Wow.
So I hope to share it with you soon.
I hope I'm there for the opening.
Bali, please, yes. Then we're building a factory for flying airships, in helium airship. So that's really exciting. Through parametric design, we reduced the amount of steel by 50% compared to our competitors who just did standard hangars. So that's how we won the competition and started working on it. That's the smile for Orange. It's a big origami. So that was to welcome the employees back. And then what's really nice when you use parametric design is you're doing systems. So it's not like a finished thing ever. It always evolves from one form to the other. And so it's creating systems instead of forms. I find that's really refreshing because you're always writing the algorithms.
Absolutely. Yeah. You always optimize it. You always analyze it. You always keep an eye on the behavior of the system. That's
and you
great
can
features of parametric design.
That's exactly. Different materials. We've been exploring biomaterials a lot. Mostly PLA, which is a sugar-based plastic. So basically, instead of having petroleum-based plastic, we're trying to find something that's renewable, compostable. So a lot of these projects are made from this. We try and find pigments that are also non-toxic. You'll see a lot of these wavy pattern around our studio.
Absolutely, like that's the basic ideas that you are mainly focused as well. Like I've seen even the wooden versions of it that you did for a couple of projects.
There's a few reasons why everything is wavy. Number one is when you print and you create something that doesn't have too much cantilever, it doesn't collapse. So a lot of what we do is based on that constraint, that it doesn't collapse from its own weight. So that explains a lot why the things that you see have this kind of wave. You see, 3D printing is a little bit like masonry. If you go too much, then things start to collapse. I mean, it's still beautiful when they collapse. We have a few examples of collapses.
Even that one is beautiful.
I know, right? Sometimes, if it's sort of understood as part of it. So that explains that. Also, you'll see there is a certain way to tile these waves. You'll see it in the wooden wave when we go to the factory. And of course, the flow. I really enjoy the wave and the idea of flow. It's in the name, in Mamou-Mani, in the logo. Actually, I realized my name also means sacred water. So my dad is from Tunisia, North Africa. And apparently in Amazigh, which is there's a tribe in North Africa called the Amazighs, and it means the sacred water. And I didn't know that, so it's really beautiful, yeah. So this, for example, is what we put below the man at Burning Man. So you had a few of those around. And basically we let the material sort of sag. And so he created these domes inside these shells. In this case, it's a failure that worked.
Yeah, it looks crazy.
Yeah. Okay. This was an experimentation we did. So you see this wire here. They diffuse light. So basically the idea is to have light diffusers. And to do this, you cannot just model this in 3D and then slice it. Usually people do that. The movement of the printer is what we model. So that's what we send to the G-code. G-code is what we send to the printers. Yeah. So we try and use the actual movement of the printer as a way to design, which is a bit of a different way to think. So you'll see all these patterns. We call this a mystic rose. This is one of our table, by the way. Yeah. And so you see that here you have this interconnected elements, and this is because we are modeling this with lines rather than meshes. So that allows us to control the speed of the printer, go as fast as we can, and then just play with what a printer can do. You see? You'll see this, for example, the textures. It looks like it's almost woven. This is the award for Fortnum & Mason. Yeah, so it looks like someone had done basketry. Yeah,
each layer.
Yeah, exactly. This is ceramics. So ceramics has been a really...
printed?
Yeah, it's printed. So
it seems like an organic,
yes,
natural...
it's like a coral, right?
Yeah.
Here, it's a nice hat as well. So this was printed at first, and then we did a mold, and then we used what's called slip casting. So we put liquid clay. Yes, exactly. This was much faster than printing. So printing can be slow, especially when you mass produce. So there's a moment where you need to shift when there is a lot of quantity involved. And so that was slip casted from a 3D print first, then a mold, then this model. And this was used as on the wall of a restaurant, a lot of them, to create a bit of an ecosystem of a coral with planters. So they're actual planters to plant stuff. Yeah.
Can you put them in the sea as well?
Yeah. So
just, you know, the coral...
the coral printed project.
Yeah, coral printed project, but also the coral, all those animals, with sea animals living inside the ocean, they have this danger of, because all these corals are being destroyed and they disappear.
Yeah.
They don't have anywhere to reside or go for foods stuff. That 3D printed project was also to acknowledge this disaster that's happening, but also help the sea life to reform.
Yeah,
or
to rewild.
Rewild, yeah.
I love these projects. When you're not just helping the environment, you're actually pushing it to thrive. So,
and with technology, with our own tools, we are able to bring
help
life back for them.
Bring life back. Yeah, I mean, you know, obviously nature is a massive influence. I'm always amazed by, you know, what I see. Like, there's no greater inspiration. I'm amazed. So this is a piece of coral, but you see, you have the branches, and then they touch each other. So it's not like you have different branches separate like trees. They actually create a network.
Yeah, and a unique system.
Yes, exactly.
One system.
One system.
Yeah,
exactly.
one system.
Exactly. So I really love seeing that. Another one that is a big inspiration is this. So this is a dried cactus. So it's very fibrous because of the water that you need to place, of course, and keep in a dry climate. So I saw this in Peru. Yeah, incredible. And that's like just one layer. Look at this. There's so many layers. That's why I love observing, because nature has gone through billions of years, you know? It's like its own AI.
Yeah, absolutely.
Natural intelligence, NI, natural intelligence.
NI.
Yeah, exactly. So that's actually quite nice. These are some of the sketches I do. So
These are your personal sketches?
these are my personal sketches. So I really like to just sort of, when I can, obviously, when I have time, to just let go a little bit like parametric design, but by hand. It's a bit of a strange concept because usually when you think parametric design, it's on the computer, right? But actually, the computer, what it does is just make you think with geometry and association. But you can do this with hand. Like if you start a module and you just change rotation, angles, you play with tangencies, you start like creating rules, you know, and scaling and, you know, arrays. Like all of this can be done by hand, you know, the modular approach, and so I really enjoy letting the hand, because you have a certain freedom with the hand, but at the same time applying the constraint I've learned in the computer.
Yeah, analog.
Yes,
parametric
exactly.
design.
So it opens up perspective. Sometimes I'm like, oh, that would be a nice tower. Oh, that would be a nice structure. And
No,
so
I'm so happy
yeah.
to see these sketches. And even in the studio, we had workshop together.
Yes.
You told the students to go with hand
True.
drawing, then
True.
go to parametric design.
True.
And the whole workshop was crazy and awesome. Like, you know, very
That's
fascinating.
a good memory. I like
Yes.
it. I remember the mushroom topia.
Absolutely. Oh my God.
I saw you went to see her
Yes,
studio,
yes,
right,
yes.
Elena? Yeah, it's nice. It's
Eliana,
really nice
yeah.
to see, you know, those projects thrive. I think it's really nice to go and be out of your comfort zone and try something you're not familiar with, and seeing where it leads you to, and trust the process, and trust that it will be okay. Like I think that's what I like. I came from the, let's say, the computer world, so to go back to hand sketching was a bit weird for me. So I'm like, oh, it's too much freedom. But at the same time, I'm like, oh, wait, why do I put them in boxes? Why can't I just draw just like the way I do it in the computer?
Okay. No, I like that you're not just only relying on the computer environment. You start from the sketching, and then you have some ideas that you want. That are inspired from nature, and you want to decode them and bring into our physical world. Yeah, that's absolutely incredible.
Sort of circular center. So basically we have recyclers, we have crushers, we have a yard where we use our, we call them sort of waste, but
trash waste.
But there's no waste when you think in circular ways, because you can put it back to the
production line
and to the production line. So our hope is to really close the loop in here. And so we have this entire building now, which is really, really nice. And we hope to develop over time. So we're separated by this passage, the passage of death,
cool,
as we call it.
Cool.
It's very cool.
I love it.
It was very scary when I first came, but then actually it's totally safe. It's actually where the libertines.
An area for parties here.
Exactly,
Parties, hanging out with all these FabPub guys.
Exactly. So it's you know, the Libertines, the rock band, they had their video here. It's quite a legendary passage.
Wow.
It's really nice. I mean, eventually maybe we need a bridge of sort, but I really love this passage. It's really East London, you know, it's totally East London.
East London vibe.
Yeah. So this is where we started. So this was an empty yard. It had stray dogs. It was like a car repair. And then my friend Tim, he's the landlord, had this idea to place containers. Containers are small enough that you don't need to worry about the council tax, which means that you can really optimize your expenditure. This is really nice. This is an old brewery that was bombed during World War II. It's the last remaining building that's just standing and bombed during the war, which is kind of crazy to think of. But I find it's a very beautiful relic of the past.
It is, and it creates this vibe of like old, new stuff together.
Exactly. It's really, really unique. We'll go upstairs and I'll show you. So this is a really nice little yard where we all come together. We have NEPA, our little sort of restaurant here, and this really allows the team to come when it's sunny and relax. And we had a few containers, and people would use the containers from outside and could book the lasers and so on. And now we brought everything back to the new spaces. To me, this container is such a nice concept because it means, one, you're reusing elements, you're recycling them, you're finding new purposes, and if one day they need to change, they can remove them and reuse them somewhere else. So it's a very, I think, profound way to think of architecture, something that can move around, be reused, not permanent, you know. So we leave our material outside. We're trying to build a bit of a weathering section. station. And so this has been a planter for, I don't know, about 5 years, and it's still intact. So it's really important for us to see how much sort of warranty we can offer to people, to our clients, because they always ask, but it's biodegradable, it's going to, you know, break and be like, and I said, well, it all depends on parameters. It depends on the thickness of the element. COS was very, very thin. So obviously it's going to be fragile. And yes, eventually it degrades, right? But that's what makes it so environmental. If things last forever, then it's completely contradiction. Yes. So we try and explore that boundary between what lasts, what doesn't last, and what can, you know, what can we control? Can we control biodegradability? The more we are in control, the more we can tell our clients you're safe for X amount of years. And then we'll crush it and reprint. But we need to be in control of that, because otherwise it's at risk, right?
Yeah, we have to take care of the next generations that are coming,
exactly.
like our kids, grandsons, grandchildren, and it's very important, of course.
There's such a paradox between, you know, durable, like lasts forever, and biodegradable, which means it degrades over time. And it's this very kind of interesting notion between organic material that can degrade and inorganic material that cannot degrade. But inorganic material needs to be mined, so it depletes. But organic material you can grow, and then it sort of renew itself. So finding the balance between the two is what I find very interesting. And it's a complete journey of discovery. So this is the waves here. The idea behind the wooden wave, to create some slits in the wood so that we can control the bending of the plywood. So a while ago I did a project called the Magic Garden for Karen Millen, which was using fabric and pinching the fabric. And Burrow Happold, the engineer, said, can you do it out of wood for their interiors? And that's how the concept came about. And then there was this amazing guy, Aaron Potterfield, who put online some open source technique to bend the wood.
I know Aaron.
Oh, you know Aaron?
I know Aaron.
Great, okay. Yeah. Super cool, very collaborative, shared the technique. And then we put it in Grasshopper and try and bend the lattice in order to create these waves, you know. And so remember when I said the waves are good when you print? The waves are also really good for continuity. So this is tangent to the edge, and therefore it creates a bit of a tile. So when you put them together, it looks like a continuous element, but it's made from module. Yeah.
So I assume, like in this case, it's just 4 modules that are repeating.
Yes, exactly.
And you can adjust them based on your space.
Exactly. You can adjust them, and it's bespoke, so you can do, like, that's the good thing with digital fabrication. You can personalize to the dot. So if you tell me I have X amount of centimeter, we can do exactly that. We don't mass produce, we don't buy products, you know, we can really go very precise. And so people love that, because usually you're constrained by the system, where here you create the system. So that's been so much fun, actually.
I love that, by the way. I need one of them in my office.
Yes, please. Yes. So this is more of our failures, experiment. We keep them because they're just too incredible. So this one collapsed. We still put it in the oven. I know, right?
It looks beautiful because it looks like a ramp or something.
I know, right? I mean, that's what I love, you know, like, I love not knowing what to expect. Like, that's what makes me excited to come to work. Like, I just don't know if things are going to be successful or not. And so we play with that, you know. These are some of the glazings. And I just thought it was nice for people to touch and feel, you know. You can only do this at product scale, right? Like, you don't go and caress architecture. I mean, you could probably, but here you can really feel the textures and add, you know, even the touch and what it feels like. And so I think it's nice to experiment with other senses.
Like, we are designing in larger scale, but also experimenting in smaller scales.
Yes.
Even if it is like a cup scale or like, and you're getting the same principles, ideas, and apply in architecture scale.
I know, people think like, oh, but you don't do architecture, you do temporary, a pavilion, this and that, or you do cups. And I'm like, well, there is architecture in a cup, just like, you know, a pavilion can become a skyscraper. I
they
think,
don't understand architecture.
Yes. Thank you.
They don't understand design.
Thank you. I think people like to put people in boxes, you know, you're this or you're that. But why?
Yeah,
you know?
just putting boundaries and
Yeah,
limiting.
putting boundaries,
No,
exactly.
that's absolutely
Yeah.
not true. Not
I
correct.
love on parametric architecture, you're displaying any scale and you're working on any scale and completely open to that idea.
Yeah.
Yeah, so that's the printer I first installed when I was 20.
Homemade?
Homemade, yeah. It's called a rep wrap. So the notion was to print a printer that can print itself. It was a British doctor called Adrian Boyer who had this concept. And then it was just really fun to see how things work.
Wow.
And I thought, you know, I might as well learn about the hardware and the software so I can maybe help do a craft that's more understood. Not something superficial where...
When you made those, like 20 years ago?
That was
30.
I was 13 years ago, or
13
yeah,
years ago,
something
wow.
like that. Yeah.
Cool.
Nice.
And then there's this one.
Yes. So this is made from paper, actually. It's a pod that we were printing for a scanning. So basically, it's a company that scans people and use AI to tell you if your posture is good and what kind of exercise you can do to reposture yourself. It's called FI. We're part of a bigger ecosystem called Thermic Group. So they do big well-being centers. And so it's been amazing because they also have companies that deal with well-being, and they have a robotics company that we can tap in. So we're part of a bigger collaborative ecosystem of companies, which has been amazing, by the way. So this is one of the cells. So everything is modular because the printers have a certain size. So we're always thinking like, what could be the modules? And so here you go, another kind of wave.
This one, full one
This
scale.
is an entire, imagine an entire sort of building like this, right? So we print flat. So you know, you print flat, and because this is a curve, we have to think of how to absorb curvature. And so you see the different links. So we did this just to understand the link between flatness and curvature. And so we do this quite a bit, full scale to test.
And all these one was printed in one
Each
one
module
piece,
printed in one piece, yeah, with our 3MT, the WASP 3MT that we have here. So we always think which printer for which solution. Sometimes we use the robot, sometimes we use the slightly smaller ones. We even have a farm of Prusa, which is, yeah, it's crazy, I know.
Crazy printers.
Crazy printers, and they're really lovely to experiment on a smaller scale, and they print really fast. They're really nice printers, actually. This is also one that I haven't published yet. Hopefully we can show it first with you.
So there's a lot of things to cover.
So these are lamps we're doing for, it's called the Chalet Alpina in Switzerland. And basically it's inspired by the chandelier we did in Edinburgh, which was in a church. And they like the intricacies of it. And the thing is, we print it flat. So we print all these things flat with sugar and a brass-like additive. So slightly metallic. And so you'll see it's very, very detailed because you see the shadow gap between the elements. We print flat and then assemble it together, which makes it like a bit of a jigsaw, a puzzle to assemble. So you can see behind Baloo is the prints, the flat prints that we're printing in sequence. It's quite beautiful because you have the template behind, and then we're printing them in quarters. And so as we print, we put them up, and then people know how to assemble them together. And so this we're printing with the 4070s, which are slightly smaller printers, but it's pellet based. So we can put pellets instead of filaments. I'll show you what I mean.
Sure.
Yeah. So these are some of our stools. Yeah. So they're actually really nice and comfy. They're called a mandala stool. We still have to remove the base, but. So this is for a restaurant in Covent Garden. Also an unpublished project.
I've seen this.
We haven't, oh, the stool, yes.
Yeah.
So it will be part of the bigger bar. And basically, we've done it exactly to the dimension that the client wanted. So we use our files, we vary them parametrically, and then we print them. So they're printing now at the moment. So we're printing them out of here. This is the sugar and wood flour. And so it's
These are made.
These are made. These are compounded to this, and then after that, once the print is done, we can actually put it back in the crusher if we need to. So all these printers are linked to our compressor, and then the compressor, sends air everywhere, and then the air sends it to the nozzle, and then it prints from this. So all the machines are interconnected by the air pressure. Yeah. And we turn the PLA into ceramics.
So beautiful.
Yeah. So this was for a restaurant in Canary Wharf, East London. Yeah. So it's nice for
ceramic. This is ceramic.
This is ceramic, exactly.
This is plastic.
This is plastic, bioplastic.
Bioplastic.
Yeah, bio.
Bio. Let's add that word.
So AJ is removing the brim, which is what holds the print onto the base. And this is for a project that, again, non-published project, that we're going to put in Pancras, St. Pancras. You know where the station, the train station, St. Pancras International, is just next to it. And it's called Riva, and it's going to be a very big metal version of our waves that turns into this wood wall installation with the light that you have here.
So after printing, are there cleanings needed to do for these parts, or is it just for the connections to the ground?
It's just connection to the ground. This material is actually a compounding material. So we take a bit of sugar-based PLA, then non-toxic fireproofing, and then we merge it together, and then we use that for the robot. And that means that this is compliant with fire regulation. Still bio, so still environmental, but fireproof, which is the big challenge with plastic in general, but for us even more of a challenge because we want a bio material that is fire resistant.
Yeah,
so
absolutely.
This has been quite a nice discovery.
And this one seems to be a little bit
It's
large.
huge. It's
How
huge.
did you print this? It's one piece?
One piece on the robot.
One piece?
Yeah.
Wow.
So this was a 36-hour
With that
sprint.
one?
With that
black one?
That black one, yeah. So this is Her Majesty. It's our biggest robot. So this can print about 3.5 meters by 3.5 by 3. And so we printed Autostrata, for example, with it. Yeah, this opens up all kinds of new possibilities for us. So we have 2 of those now. And it's really useful for large scale stuff, like for the architectural scale. Interiors, you know, a lot of clients that have hotels, restaurants are really interested in that because you can print unique things. And so people want to tell their own stories. And so if you can print something unique, you can be a unique place. And I think that's why a lot of people love 3D printing.
Yeah, this is 6-axis or?
Yes, it's a KUKA robot, and it's it's been a bit of a process of discovery because it's quite new for us, and so there's a lot to understand. It's a lot more complex than Cartesian or Delta 3D printers. It's you know, the link with Grasshopper, how to actually do the toolpath, how to level the bed because the bed is so big, like it needs to be leveled. How to feed the material, and it can absorb and release a lot of material. So
it requires a lot of tests.
It's a lot of tests, and each tests are huge. It's not like you do a small test and then, you know, like so we ended up using a lot of material. So our recycling center became even more important. So we had to, I'll show you later, we had to buy a huge crusher because we went from small quote-unquote waste to these giant tests. So
you're right.
Yeah. So we do a lot of these tests. So these are some of our tests that we do.
You sampleize them.
We have it code. We have our Notion page, our wiki, where we feed the information.
So your archive is also in place.
We have our internal Grasshopper plugin where we do our own sort of.
Other than Silkworm?
Yes, an extension of Silkworm, but with more stuff. We have to do it because we need to share information. So as soon as this is printed.
Do you share it anywhere, or is it just inside us?
So Silkworm is open source. And then, not quite ready yet. It needs to be sort of packaged and ready for people. The thing is, you know, like even for us, I'm not quite sure if it's completely ready until everyone uses it, until everyone sort of feeds back, until it's really useful for us. I don't know if it will be useful for others. But yes, I mean, you know, we love the idea of sharing. So, you know, we've always been in that spirit of exchanging information. I'm a teacher. I taught the PA Academy. So I think it's important once you start doing things to help the planet that you actually spread and have a bigger impact, because otherwise it's not as efficient.
Absolutely.
we don't have enough years. We need to share.
Absolutely. Without sharing, we don't grow.
Exactly. So this was the Alto Strata wall. So this is a huge piece of our pavilion that we did that traveled around. You know, the last one was in Dubai Design Week.
Recently,
Yes. And so this is basically like a diagrid, you know, the truss. It's like a truss because you see it connected as a diagrid here. And they come together. So the forces are really well distributed because they go on the outside wall and then they pinch at a point here. And so it actually worked really well. We did a test to pull it and it resisted 500 kilos per meter square. Even the engineers were surprised by that.
So how did you print this in that?
On the robot.
But layer by layer, and then you connect it, or is it just one piece?
So this is one of our failures. Yeah, I love failures. And so we had 12 of these modules put together side by side to form the pavilion. And they were all printed to the max size of our printer. So you'll see all our pavilions, conifera, etc. They're always constrained in a way by the size of our print.
Of the machines.
Yeah, so always trying to think, okay, what's the production capacity? What can we print? And therefore, what's the pavilion like? Also the one with Sandway, with Chris Brecht, same. Like, what's the size? What's the machine? What can we do?
Yeah.
It's thinking upside down, you know, like, so these were put together.
But again, these limitations sometimes I push it towards like creating, you know.
It's amazing.
The same modular stuff, the same box packaging that you can make to put them together to form the entire structure. And like making a prefabricated structure out of 3D printing. That's also cool. I mean,
yes.
If you would print the whole structure in one piece, that would be quite hard.
Well, look, I think if you start thinking of architecture in general, there's always some kind of module. Like there's always, you know, the beam, the roof, the canopy, there's always a constraint, and often it's based even on access, on transportation, right? Like even the machine that will print is based itself on the size of a truck, right? So whether there will be these magical machines that will print everything in one go, I don't quite believe it. I think we'll always have to think in terms of modules and assemblies, and therefore we have to know this constraint. I like the sentence like the truck is a designer, you know, the truck is a designer. It's very humbling to think, actually, I don't just need to know how to code on Grasshopper. I also need to know what truck I'm going to use to deliver my piece. And, you know, do I need permits, and how is this going to, and is this something that people can lift, you know, or will I need a machine? What about, there's so many like questions of practicalities that inform why this is the way it is. And I think for the new generation, it's very important to think this way, and therefore get hands-on experience. Like when we did the products, I went recently to install them, and I'm like, damn, that's hard. And so we improved them based on just feeling, doing it. Like when we build Galaxia, we were with the drills, you know, installing, placing, lifting. So then I think the next time it's informed by that, you know. So
absolutely, no, that's incredible. And sometimes because of those considerations, you start working on the structure in much better way. You optimize it. And you then, people are going to carry this by hand.
Yes,
so, how
so
can
they'll
I
like
make
you.
It lightweight?
Exactly. Health and safety, and there's all kinds of consideration, and people enjoy if you take their feedback into account. If you speak to a carpenter, if you speak to even a truck driver, like how to pack things efficiently. And so that's why I really encourage humility and like learning, continuous learning. Because when you think about all of these, there's so much to learn, so much. And so it's a never-ending journey of learning, really. Yeah. So this is our yard. So we try and keep everything and throw as little as we can. And not just because they're beautiful. I mean, they're, you know, we tell our staff they can come and pick it up, so if they want to keep it. But also because we have our crusher here, so we are slowly digesting our waste, which means that eventually these are going back to be printed into new stuff. And I think it's a really important concept nowadays, because we can't really afford to have more plastic.
Waste to the environment.
More waste to the environment. So that part is something that is dear to my heart. It's not, you know, look, it's still a process. We're trying to figure out how to best crush, how to recompound, how to create pellets and filaments. There's a lot to learn, but I'm happy we started the journey, to be honest.
Yeah.
Oh, nice.
Incredible. Thank you so much for all your efforts.
Let's hope it leads to something where, you know, we understand materials better. So this is our laser zone, so people can book them online and come and use them. We try to open this to the community, and they book it online, and so we're still setting up here because we used to be in the containers and then we moved here. So it's still ongoing process, but it's really lovely. Our hope is that we'll have a kind of public shop, so people will be able to come through the yard, maybe see some of our discarded elements.
Yeah,
you know?
maybe an installation here to showcase.
And then come here, use our lasers, and we'll put printers here, and then kind of let people sort of enjoy our ecosystem a bit more. I've always wanted to have a public sort of, you know, shop front, but it's always been hard. So it's still an ongoing journey. Cool, so that's our smaller crusher. So we started learning about crushing through this one. So here, this is how it comes out. So this is the sort of wooden material, yeah. And so now, how do we bring it back to pellets? How do we compound it back to use to the printer? So now we need a pelletizer and then a filament maker. Strangely, so we have a wood shop because we are doing timber structures and substructure. That's the thing about our conversation about pressing print and have a giant printer. It's never the case. You always have substructures. You always have like other things, you know, that you need to think of because you need to attach to, you know, concrete buildings. That's the thing, like, we're dealing with a city, and so cities have stuff already built, and we're not going to destroy what's been built, so we need to adapt to what's... So for that, you need to have assembly techniques, scanning technique, augmented reality techniques, so that you adapt. Yes.
on top of
and so that's why we have a wood shop. We have... thankfully, they stopped me when I said I want a metal shop.
No, Arthur.
No. So here you have the chandelier. We called it Briar, which is in Edinburgh, and it was a very large, 3 meters wide chandelier made from the sugar and the brass-like additive, and it's really nice because I remember seeing these traceries. So in Gothic architecture, you have these beautiful sort of stone cut to form this lattice. And with 3D printers, you can take something and turn it to a three-dimensional geometry. And so I was like, okay, what if we take some of these inspiration, print them, and then array them and create a three-dimensional object inspired by that. I really love this
creating
notion.
a new definition of those small unit geometry.
Yes, exactly.
Creating a bigger unit.
Yeah, it's really nice when you take the wisdom, you know, of the past, especially when it comes to church, to mosque. You know, we talked about Muqarnas and so on, and then you turn them into three-dimensional parametric elements that you can vary, print, you know, array, and tell a new story that is still inspired by the past.
Absolutely.
It's you know, almost like archaeology.
Great. So thank you so much for the great tour that we had in FabPub and also the workshop section. It's nice to see how you are emerging all these tools, technologies in your design process. So thank you so much for the tour.
Oh, my pleasure. It's an honor to have you here. You know, I've been following parametric architecture for a while. Obviously, we did the workshop together, but it was all online,
All
you know?
online.
And it's something to come and touch and see and understand, you know. It's, I think it puts another perspective, and it's so nice to be able to share our ecosystem with everyone.
Of course. So we saw so many things in this last hour. So I'm just curious to hear this story. How did you get into architecture? You became interested in building stuff and building projects or architecture, actually.
I guess I was always interested in geometry, mathematics, and art. And I don't think there's many professions that allows you to explore both sides like architecture. And my father is a computer scientist, and so he would teach us coding and so on. And I was in Paris and studying architecture in Paris, and I struggled to understand how I could link sort of the architectural side with the computer side. And only when I came here to London, I studied at the Architectural Association, and my schoolmates were Neri Oxman, Ahim Menges, and I remember seeing their presentations and thinking, that's it. That's it. Everything was very natural and yet influenced by code. And so it felt like you could use the computer to go back to nature. And I think that was a really interesting moment for me. So that's sort of shifted the way I thought about architecture.
Mm-hmm. How did you become interested into the world of parametric design, computational tools, and also digital fabrication, robots, 3D printing? How did you become, how these stuff started to getting into your life?
So I remember about when I was, maybe 13 years old, I remember being in school and the teacher was showing us a coding language called Logo. It was a little turtle, and that little turtle, you would tell the turtle to go somewhere, move, and then do it over and over and over. And I remember staying after school because the turtle just kept on forming these amazing, galaxy-like, and so when I came here at the AA and I started seeing that you could use the computer to generate form as opposed to draw them and impose them, they would sort of emerge and you never knew what would come up. And so I got really excited by this notion of playing with the unknown, the parameters, and then tweaking them and then seeing what happened and tweak it and see what happened. There was something more of a discovery process as opposed to, I need to know everything in my mind, which I thought was a bit overwhelming. So that's how I discovered parametric design. At the time, it was called generative algorithm. Generative component. You got it. And it was really obscure and sort of you had to write down the steps, and then the tree would appear. And but I did my entire diploma project about Oscar Niemeyer and tried to parametrify Oscar Niemeyer. So I could bring the sun and test all these environmental geometries. So I did my diploma on that. And after that, I graduated and I remember someone saying, "Can you teach Grasshopper?" And I'm like, "But I don't know Grasshopper." Parametric tools, it's all the same. And so I worked during the week, and then on the weekend, I would teach Grasshopper. So I had to learn it before I teach it. And so I went like this for 2 years working on this amazing biodome at work, and then in the weekend I would teach the tools. And so that's how really I sharpened my understanding of the tools. And then Rhino called me here in the UK, simply Rhino, to do all the classes for Grasshopper level 1, level 2, and so on. So for 2 years, I just went across the UK. It was amazing teaching, McLaren racing, Cadbury chocolate. And then I realized that parametric tools, they don't have boundaries. People were creating plugins, that would teach you about things like the Catmull-Clark subdivision, things that are, used by Pixar, Ed Catmull is like the founder of Pixar and has these way to create smooth geometry from subdividing mesh. So suddenly you're working with, jewelry designers, car makers, architects, designers. And so it's a really lovely way to unite everyone through mathematics and principles as opposed to categorizations of jobs. Yeah.
Yeah, that's actually fascinating. And definitely parametric tools are reshaping our industry, and they created phenomenon, possibilities to explore unexplored worlds that we can have in architecture. So what do you think, how these tools have changed architecture in the last 20 years, let's say?
I think they radically changed architecture. I remember, staying really late, drafting things by hand, almost using the computer like hand drawing, like basically not using the intelligence of the computer. And I arrived, I was like, "Oh, damn, you're doing this by CAD, like one line at a line." And then I saw them zoom, and architects are perfectionists, so they would zoom and make sure
they are perfectly aligned.
I was like, so painful. Like, yes. The computer has intelligence. Use that intelligence. Like, create software, not forms, And I think there was something extremely exciting.
What's helping?
Not using the computer just as a way to reproduce a hand drawing or something that you already pre-thought about. This notion of the designer, the creator that has everything in his mind. And if you oppose that with this idea of nature has DNA. It just sort of mutates and generates these amazing, like flowers and details and fractals and inner structure, and
patterns.
And that has evolved over billions of years, and it's just minute differences. It's like I think like of wine in France. You have so many wines, but you're just
Sipping.
sipping, and then there's slight difference. And actually, if you think of parametric architecture, they're a little bit like that. Your things are growing, and then you're just adjusting parameters, and then
that's cool. Finding the best taste. Yeah.
And so I find this a very it's a very nice, almost like being a gardener. Like instead of a kind of sculptor where exactly. It's like you're gardening these patterns. You're not inventing, everything. You're collaborating because you're using, there is Parakeet, for example. I know the author of the plugin is Iranian. And he's using mathematics to empower designers like us to let these mathematical form then become building. So we create matrices of possibilities, and then you sort of observe the matrix and you think, that feels better. That feels a bit better. But until you see it, you don't know. So I love that. I love that. You plant the seeds, you see them grow, and then you just sort of slowly.
Absolutely.
It's not so different from AI, actually.
Absolutely. Yeah. Absolutely. And what do you think these 3D printing and these new fabrication techniques are affecting architecture and the way we build, actually? I saw the structures that you showcased, but in larger scale, on how far we can go with 3D printing, and do we want to go 3D printing those larger scale models, or what is the future of these printing techniques in architecture?
The thing that excited me the most about 3D printing was to allow the factory, the means of production, to come back to cities. Now our factories are very far, and people mass produce somewhere. We don't see it, so we don't learn from it. So there's no craft anymore. Craftsmen, they used to be like down the road, you see the craft, you would learn from the craft, but now, everything is far away in some big factories. So what excited me about 3D printing is that I could have that factory here. We're in East London. We could see it, designers could see it, they could learn from it, they could work with the code, almost like digital craftsmen. And then they would produce something they could actually really have a direct relationship with. So to me, it's a
feeling of belonging to.
Yeah, it's linking the digital matter with the physical matter and creating a loop. And so it's very circular. It's very it's very empowering for people in general to see that this is something that was in the computer, but yet it's very tangible, And so for me, it's the second step, First step was, so I worked at Zaha Hadid at the time, and we were doing these amazing forms, but it was hard to relate. It was hard, and we would send to contractors, and contractors had to learn these really complex things. And I remember I worked with Mark Fornes. He was my neighbor here, and I remember one day he came back with Alvin Huang actually, and they had this amazing model, 3D printed model. And I was like, whoa. And I thought, okay, how nice it would be if actually they could create the file to print that project they were working on. Like, why? This is just a representation, but what if we could actually think of the whole thing as a sum of printed parts? Like, what if the printers were large enough to do that? And it's a crazy what if. At the time, the printers were like that, they were very expensive as well. And slowly, like any technology, it became more and more available. And so there's no reason it could scale up and up and up. So now I know Zaha also has a robot inside their studio. I know that architecture studios, they start to rethink the way to fabricate, if not prefabricate. So to prefabricate modules and then put them together.
So speaking about the new tools and technologies that are emerging, one of them is the topic of the day, of course, which is artificial intelligence. It's disrupting most of the industries and changing the way we do our tasks and daily jobs. So in terms of architecture, what do you think what role it could take in the future of our industry?
I find AI fascinating because it reminds me a bit of parametric architecture in the way that it also puts you in this position of planting seeds, of seeing what happens, and of choosing. And then you become someone who chooses and who breeds idea and let them emerge and then continue that process. So I don't see it very different from parametric architecture. The only difference is that it makes you think a little bit too fast, which means that you don't have that slower process of thinking of the logic as to how things are assembled. Or the way I see it is a little bit like Tinder, you know, you just swipe right, but you're not developing a relationship, you know. You're not getting married just yet. You're just playing a bit. But when comes the moment to build it, you have to step back a bit and think, wait a second, like, how does this work? How do you transport it? There's so much to think of, and you need to feel it with your muscles, right? Like when we built the temple Galaxia, we were, in the desert with our pieces of wood. We had to think of way to put them together. And so I worry a little bit of the disconnection between the AI new generation, let's say, and then the actual manifestation of things. And it's not a worry because I know that we already receive AI images of people that say, hey, print it. So we just receive AI table, and people say, can you send me a quote? And I'm like, but do you have a 3D file? No, just this image. Someone bought it, right? And I think it's very interesting that we receive this because I think to some extent our
Is this serious?
Yeah, it's very serious. Really? I receive a lot of AI images. You received
a 3D image that they want you to print it?
Yeah, it's not even 3D yet. It's like a mid-journey image.
Like a 2D image of a 3D image.
Do it. Okay. And so I think people think they're designers because they have access to this. And it's normal because we've always said that designers were authors of some forms. But what about the sort of nitty-gritties, the fabrication process, the constraint of the real world, this bottom-up aspect? I worry that it's giving a bit of entitlement to designers to come up with stuff so easily that they don't understand of difficulties and design in the way that I was talking about, the sort of bottom-up emerging, material constraints, like what parametric design had, which was a community of plugins that people can feed knowledge to. I worry that the AI just looks at lots of images and then sort of makes a bit of a summary of these images. And so people think they're designing things like that, but they're actually not going through that process of learning, this kind of tough learning process. They are more like form maker as opposed to system maker, which is what worries me a little bit. And the other thing that concerns me is then people might undervalue that harder process. They might think, I can do it too. And actually, no, because an image is not everything. And it's an image world. And so I really look forward to seeing how, from AI to reality, I really look forward to seeing the first case studies of AI to reality, because that's the humbling part. And that's the part that makes you rethink what's the true role of a designer.
Yeah, absolutely. Like we can even lose the sense of design if we are not super focused, or we don't understand why we are doing this, or even the prompts that we're putting there. If we're just putting them for the sake of getting the similar images, or if you're using style of Zaha Hadid or Daniel Libeskind or these star architects, I don't think that's the way we should go. Actually, that's the way we should go.
Look,
it's not a.
it's like
not a
Pinterest.
healthy. Yeah,
Remember
it's not-
Pinterest, right? You were collecting ideas, and it's like a mood board. And so AI is like the ultimate mood board. But it's a mood. It's a feeling. It's like Tinder, right? I like, I don't like, I like, don't like. The hard bit is it's what's behind. It's how to bring this to life. It's for me, for example, when we worked on the temple, winning the temple or doing the image of the temple was, I don't want to say the easy part, but it was the more abstract part. Getting to even raise the funds for it, to convince people that this needs to be built, and then building the team, and then creating the enthusiasm around it, and then the details and figuring it out, we had to commit to that form. We had to commit to it. And it's that commitment. If you can do anything, if you can date anyone, why would you marry? You know what I mean? It's similar thinking. Yeah.
Not a healthy stuff to do. Not a healthy thing to do, of course. Speaking about the sustainability and the biodegradable materials that you showcase down there, and also the topics of the day that how we can create more sustainable architecture towards the future, carbon free, and all these things. What do you think could be the path forward for architects to have a good built environment, to have a good urban environment that doesn't feed into the harming the environment? As architects, what role can we take actually?
Yeah, architects have a huge role to play in the whole environmental impact. Materials like concrete is the second most used substance by humans after water. Like concrete carbon is like 13% of all emission. Steel is 8%. Like the numbers are staggering. And then when you start including actually the houses and all the equipment that powers a house and all the leakage of the heat leaking, little things like this, like you start thinking of the house as a system that can really help the planet. And it's often in the boring things. I just did a home which took me out of parametric design. I just finished my house, and I had to think of things that usually I don't have to think of. When we're commissioned incredible projects, you don't go to the nitty-gritties of how are we going to ventilate this or how. And so when we did our house, we used things like MVHR, which is a ventilation unit that keeps the heat in. And then there came challenges like, it's an existing building. How do you turn corners with the tubes and so on? And then I'm like, oh, actually, we have a printer. So we could create
print
custom,
that part, yeah.
And so you start thinking of printing bits and pieces that are not seen, but that are crucial for, what we can. So if we're gonna retrofit, cities they're built, and so we're not gonna demolish things and always create new forms and new things and new buildings. So if we retrofit, we need to be able to scan precisely, print to precise dimensions. We need to adapt what we're doing to the built environment, see if we can come up with modules for the facade to protect from the sun, see how we in a way it's how do we not necessarily reinvent everything, but make a better consciousness of what's environmentally, what's available and what we can, I call it betterment, right? Or what we can make better, environmentally speaking. We spoke about plastic and the impact of petroleum plastic and the decision to go for petroleum versus biodegradable, renewable based. And really, that was a financial decision. And now that we understand that finance is not the ultimate value, but actually it's our survival as humans, right? Like it's more important, of course, than money. So then you think of the environmental cost of what you're doing, and then you always so as an architect, you'd always have to ask yourself, what is the environmental price of my decision? Like, do I care so much about that form that I'm willing to put the added carbon to do it? And when you start thinking this way, you're like, aluminum versus steel. Aluminum is twice the carbon of steel, but it's twice as light. What do I prove? What do I do? How do I do it? But aluminum is more pliable, but steel, I don't need a substructure. But how do I make my building as light as I can? And then you start thinking of all these things, and it's like about lightness, about attachments, about, and these are questions that are worth asking. Like, where's my material coming from? Is it mined? Is it grown? If it's grown, then it's got energy, so it's going to burn. So how do I deal with the fire? And so all these other, usually you don't really think about all that, but this is I think the new kind of generation should start opening up to these questions. Provenance of material. Can they actually measure the CO2 of that material? Do they know where it's going to end up? Also, buildings will get demolished and will get disassembled.
Yes, you have to think about the afterlife of it.
It's hard because architects, they want their building to last forever, but which building lasts forever, apart from the Parthenon and the Pantheon? But are we really going to all build the Parthenon and the Pantheon? I mean, that's the ego of architects, right? So then, containers, they're not that sexy, but amazing. You can then, so what are the containers of tomorrow? Like, I would love for architects to start thinking of all these topics.
Of course, like reusability, recyclability, and these are the important topics that every architect should take care of or should consider in their design processes, and which guarantees a good future for all of us. That's absolutely correct. And I'm just fascinated by the amount of the knowledge and also the you have, but also you apply them into your design and your practice and your fabrication. Congratulations on that part. And speaking about the notes, that I just wanted to go back and ask about the tools that you use in the office. What kind of architectural tools, softwares are you using mostly collectively in the office?
So, of course, Grasshopper is the heart. And it's not just a tool, it's a platform for other tools, right? It's a tool of tools from the community that's been sharing knowledge for tens of years now. And so it allowed us to create design as systems. So we write our own piece of parametric tools within the Grasshopper. So we slowly save all our algorithms and then put them together and sometimes share them with the wider public. It's been a fantastic enabler of design systems. But of course, Revit comes in. We have to link Grasshopper with Revit in order to generate drawings, and sometimes we use CATIA when things get too complicated and need a more powerful memory-intensive tool. Like, for example, when we did Orange the Smile, we had to bend the metal and study the thickness of the metal. So
it's like CATIA, physical behavior.
Yeah. So that becomes, Grasshopper can only handle so much memory. So CATIA was really useful it's called sheet metal assembly. It's within the Dassault system tools. And then we had to kind of model every one of those panels and then unfold all of them. So when it comes to more precise or more memory-intensive stuff, Revit and CATIA comes in. Apart from that, we have all the twin motions and V-Ray and we explore a lot of mixed reality as well. Hologram we did a giant shark bending stuff with mixed reality. We love that.
Steam bending.
Yes, so steam bending also. So trying to see digitally the mold. So we try and use it. So we fabricate. So we become the robot, so to speak. So we visualize. It's nice because we used it for cutting foam. We used it to bend metal. We used it for all kinds of. I went on site the other day for a staircase we are going to reveal soon, the Phoenix. We were on site with the client and we had the mixed reality, and then we noticed there was a corner that we needed to shave because there wasn't space, and that's because we could see the staircase live with the mixed reality goggles, HoloLens. And so it was really amazing and then he looked at me. I just went to his house and it's like, if we didn't see this, there's no way we would have
understand.
Yeah, because you feel it's a really nice to see the digital world in reality before you press print or before you manifest. So that's been really, really useful. I'm sure I'm forgetting lots of tools. There is also the tools for communication, Slack, Notion. We use Slack for communication, Notion for all our
management,
database,
yeah.
task
Project
management.
management, yeah.
It's our wiki, internal wiki. Communication is everything, you know. We talk about sharing.
Absolutely.
So for us, it's essential to have all these tools for monitoring. Also, our objective. We have a HiBob for HR. You know, I talk about things that we don't usually talk about, but it's enabled us to set objectives for departments and for us and for the people, and monitor also how the team is sort of well-being at work is really important.
So just for closing, what kind of advice would you share with young talents and aspiring architects?
I would say just know that architecture is a very, very wide world. And that if you're curious, if you're interested in how things are deeply defined by rules, and if you're curious about these rules, and if you're curious about the physical world and how it came to be, then architecture is for you. And I would not, be sort of depressed by what you've been confronted at the beginning. If someone told you architecture is tough, or you're going to be unemployed, you're going to be badly paid, all these things, like I would rethink that, because it's a real passion world. It's a place that opens up a lot of possibilities, and it helps you understand the physical world and nature and your nature and people's nature. And so it's a beautiful, beautiful job. And with parametric tools, it's not just about the built environment. It's about anything physical, and it's how those physical things came to be. And so it's a constant process of discovery. And so it's a wonderful job. And so trust that there is more than what you've been told. Trust that you can open up new possibilities. There's so much to discover every single day. So yeah, just keep going. Keep going.
Well, thank you so much.
Yeah.
Just as a final question, I know we've been connected on the internet for so long time. Maybe it's like 7 years probably right now. I just want you to give us a comment about what we are doing at PA.
I was very good friend with Marcus from Design, Marcus Fairs, who unfortunately we lost recently. And I remember that he always asked me the right question. He would always push me, and he would always challenge me. And, and I see a bit of him in you in a way. I see a bit of that energy, that you're genuinely curious and you're genuinely interested in understanding what drives architecture and contemporary architecture. Parametric design I knew it became something when my family that are not architects at all, they started saying, oh, that's parametric design. And I was like, how do you know parametric? And said, oh, we saw it on the Instagram account. I'm like, wow, okay. So suddenly what I did was relatable. And I think I owe it to you quite a bit, because you've made parametric architecture something that the general public can understand. So, and it's really important, because if there's no bridge and people cannot relate, then they'll be like, I don't understand that thing, But you're contextualizing as PA, you're contextualizing all these ideas, which can be quite abstract for people. So I can only be super grateful, and I'm sure it's just the beginning, and I can see that
Absolutely.
You've got this real talent to spread what we're doing, all of us. So thank you from all parametric designers. We owe you a lot.
Thank you so much. Appreciate it. Guys, thank you so much for watching the episode. I hope you enjoyed it a lot. Again, I want to spotlight Pacademy, an online architectural educational platform that spreads the idea of using parametric design, computational tools, and artificial intelligence in architecture. You can register and join the live workshops or watch the previous studio workshops recordings. Don't forget to subscribe and hit the bell notification so you don't miss any new uploads. Thank you so much for watching the episode. Hope to see you soon in the future episodes.